Okay, so we are on the third one. And so I didn't end up doing number 5 on the last one because as I started doing it, I realized that was like a really big trinomial. So I decided to skip that one. Hopefully just that one example kind of helped you out. But I did want to go to one of the more difficult problems. So this is one where you notice that there's 2 radicals. So in the beginning, I said you have to isolate the radical. Well, you're like, well, I don't know which one is which. So you want to isolate the one that has the most in it, I guess you could say. So like for this one, I want to make sure that this is by itself. And so when I have that by itself, now I can square both sides. Yes, you're going to have a radical still on this side. And that's going to allow us to get rid of at least one radical. So we've got x minus 1 on this side equals, now this is 2 of these. So we're going to have rad x minus 1 times another rad x minus 1. Okay, so you can do FOIL or the box method for these. I think I'm going to do the box and I'm going to do FOIL just to show you the difference. So if you want to do FOIL, then just hold tight. Okay, so x times x gives you x squared, but because it's an x squared inside a radical, they basically end up going away, so you end up with just an x. Okay, now we've got -1 times square root of x is just -1 rad x. Same thing here, we're going to get the same thing twice here. And then -1 times -1 is a positive 1. Okay, so we end up combining like terms on our diagonal. A -1 and another -1 become a -2 rad x plus 1. So when you multiply these two together, this is what you should get. Now, if you did FOIL, you would do this times this gives you x squared underneath a radical, which means you can take it out of the rad to become x. This times this becomes -1 rad x. This times this, -1 rad x. And negative times a negative becomes a positive 1. When you simplify, this is what you get. Okay? Now, we can't forget that we still have this x minus 1 on this side. Okay? Well, now we have, the goal is to now figure out how we can get this radical to go away. So let's see if we can simplify some things. So I'm going to try and move things away from this radical. I want to isolate this radical now. So I'm going to subtract 1 over here. At the same time, I'm going to subtract x to go over to that side as well. So now I'm left with -2 rad x equals, now my x's go away, so that's a good thing. And I'm going to add these two together to get a -2. Well, this means -2 times rad x, so I'm going to divide by a -2 to get rid of the -2. So -2 times -2 is a positive 1. And now I'm going to square both sides to get rid of the radical. So now I get x equals 1 times 1 is just 1. So here is my answer. Okay, now the last thing we have to do is check for extraneous solutions. So if 1 doesn't work, we'd actually say that there's no solutions. But let's go ahead and check to see what happens. So if I take my 1 up here, here's my original problem. Square root of 1 minus 1 equals square root of 1 minus 1. So square root of 1 is just 1 minus 1 gives us 0. 1 minus 1 gives us 0. Square root of 0 is also 0. So yay, it works. And our number is 1. Okay? So just to repeat what we did, we started out and we squared both sides to get rid of one of the radicals, the bigger radical, the one with more things inside of it. And then once we got rid of that one radical, then we had to multiply these 2 binomials together. Once we did that, we isolated the other radical and we solved for that variable. Okay, so I have one problem for you to do. Try it out and we will see how you do.